In this case scenario, I hope you will also like today's topic regarding wide area Bonjour. I have opportunity to speak with some of you regarding this protocol and what it's meaning, so I hope you will able to enjoy it as well. My name is IgorDovhan, and I'm your today's speaker for this current session. And I just want to let you know that I'm super excited to be here, as it is my first Cisco Live event in general, and I'm also first time as a presenter. So I hope you will also enjoy it. Before we will start and continue, if you will have any specific questions regarding this solution, please feel free to join to the WebEx group chat where you will able to ask it, and our seniors will able to find answer on it. And afterwards, in the end of the session, we will have dedicated Q&A time, so we can discuss our questions and find answer on them. During this session, we will take a look and understand what exactly is Bonjour, why we are using it nowadays, what challenges it can bring in enterprise network. We will take a look how Cisco resolving them with using local and wide area Bonjour. We will take a look how simple it is to implement in your current environment without any major changes. And finally, we will take a look how versatile this solution, where you can implement, in what exactly network deployments. And we will demonstrate short demo where I will guide you from zero configuration to full configuration of this protocol in your environment. And for people who are seeking some additional and technical configurations guides, we have appendix prepared. I will, during the session, saying, guys, we have more information in the appendix. So if you have any specific questions, you can look at them and afterwards ask them during the Q&A. So in this case scenario, let's take a look and remember what exactly is Bonjour. So Bonjour is an Apple protocol that was invented in 2002. It is zero-conf solution, what included in itself hostname resolution, address assignment, and service discovery. It was done with one single idea in mind to bring any services in your local network to the customer without any configuration from inside of the user. And it is using multicast DNS. We will take a look and understand why it is in the next slide. And most probably, nowadays, many users will use this solution even without realizing. For example, when you're going to your home network, you will connect to your wireless device, and you would like to share some movie using your Apple TV from your mobile phone and connect immediately to your TV, or Chromecast if you're using Android. And in this case scenario, all these applications under hood will use mDNS solution. And this will work amazingly without any problems in local environment, because this protocol was designed to support it. But what about enterprise? Because nowadays, for example, in schools or in the hospitals or even enterprise solutions, a lot of people will bring their devices where they would like to have same experience, where they would like to get access to the TV using mDNS, using AirPlay or Chromecast. But here where it's challenge is coming, because this protocol was designed to work in one single IP network. We have TTL of 1. What it's meaning? With protocol, it's not routable at the moment in your enterprise environment when you want to pass it from one VLAN to another. And nowadays, we all know our networks are complex. We have multiple VLANs. We have IP routing. Our network going to overlays right now. We're trying to utilize SDA or using BGP VPN for enterprise. And in this case scenario, we have whole another layer of challenges to introduce Bonjour in our enterprise, because our end clients and users would like to use it. We would like to have same home experience. We don't understand why it's working home amazingly, but when you bring in the office, you cannot use it. You cannot find IP printer. And here, in this session, we will try to answer on all of these questions. But before we will continue, we will go a little bit back into history to understand why this protocol was designed in such a manner. As we all know, Apple have a history for service routing protocols in general. For example, AppleTalk. In 1989, Apple introduced phase 2 for AppleTalk. And in this case scenario, network industry was going in two different directions. They was going to using TCP/IP protocol, and they also was using different protocols at the same time, and afterwards some customers was utilizing AppleTalk because how simple it was to implement. You just connect all the devices and magic happened, it's working. You don't need to do any configuration. You will be able to see file sharing system printers and communicate with your employees. Because of it, Cisco and other different vendors starting supporting this protocol as well. We introduced AppleTalk routing in the same year, 1989. And this journey was going almost for 20 years until all your industry, internet industry, decided to use TCP/IP routing, and in 2009, Apple decided to bring for end of solution and end of support of AppleTalk. And so did we. Cisco stopped supporting AppleTalk. But as we all may know, this journey didn't finish here, because Apple continued to supporting service routing, but in very different way and manner. As I mentioned before, in 2009, we introduced Bonjour, but we decided to make Bonjour open solution for everybody, for any industry. And because of it, in 2003, we started working with ATF on the documentation, and after some conversation, we decided to call it not Bonjour, but mDNS. So this is why this protocol open for any companies to implement and to use, and nowadays we will hear mDNS. But in reality, beginning was from the Bonjour. So where we may have some, like misunderstanding, if it's Bonjour or if it's mDNS, it's all the same. And nowadays, in 2023, multiple companies implemented in their applications mDNS for using in very end user devices and applications, because it's so simple for end customers to configure it and get access in home environment. For example, Google, Amazon, Apple itself, of course, and Windows right now natively supporting all this mDNS. Windows starts supporting it from Windows 10. And it's so popular nowadays, what everybody is using, but we have, and we don't speak, one challenge. Almost for 16 years, we didn't have proper solution for bringing these Bonjour services and working correctly in enterprise environment. Until in 2019, we introduced wide area Bonjour from Cisco side. And as we know, today it's not 2019, wide area Bonjour have several iterations, several updates. We have some quite new features, what we'll focus on, and this session will be all about it. So, before we will go and saying how Cisco solution is beautiful, we need to understand what challenges we have at the moment and how we implementing routing in enterprise. So first of all, let's take a look in the simple layer 2 environment. When we don't have any switches, where we have flat layer 2 networking, Bonjour services or mDNS will work without any problems. It will work perfectly. But when we will add layer 2 switch with multiple VLANs, for example, in this case scenario, we will not able to advertise and send Bonjour services or mDNS services from one VLAN to another one. Same will happen if we will introduce layer 3 switch. So because of it, in 2014, when we have increased popularity in bring your device to the network or any schools or hospitals, Cisco, as one of the industries, what it did, it's introduced Service Discovery Gateway, or also known as local gateway. It was done already in 2014. And what was able to do with it? Cisco device, what supporting this solution, was able to route with protocols, mDNS protocols, from one VLAN to another VLAN, or for example, from one IP network to another. So you was able to do routing of these services at the moment. But problem is coming here because nowadays we don't have one switch in your network. We don't even have two switches in our network. We have routers. We have, again, IP routing. And in this case scenario, local gateway or SDG agent would not able to route these protocols from one agent to another one. It was not possible. And this is bringing us to single local gateway problem. And all of this bringing to no end-to-end solution, and also, not possible to scale enough and fast, because this solution cannot work in enterprise. We cannot connect to each switch needed, printer, for example, or TV, or whatever you need in your enterprise solution. And what industry decided to do, how we decided to mitigate it, how to resolve this problem. we said, okay, let's bring all our clients who require these services and connect them to the wireless. And afterwards, somehow extend our layer 2 flooding and bring all the services what connected from wired side up to the wireless controller. And in this case scenario, it will become our main cache data center and proxy for end users who connect from wireless, get information and access of these Bonjour services from the wired side. And it's also known as service on the stick model. And till nowadays, a lot of customers using it without any problems until they need to scale the solution. And also, this can be familiar to router on the stick model, as we all know, and again, it's used till nowadays, but only for services. And as I mentioned before, it will bring you, again, single network visibility, because sometimes you cannot extend all your layer 2 flooding up to wireless controller from your switches. Afterwards, it will be, again, limited services, and it's, again, bringing flooding to your layer 2 network, because you don't want to have a lot of layer 2 flooding in the network. It's impacting your performance in network devices. It will impact your performance on end-user devices, because they will need to accept all this data and do something with it. So we would like to avoid it. We would like to have layer 3 IP routing in our network. And finally, it's, again, not scalable, because if you will have massive school, you cannot do layer 2 network everywhere. You need to have somewhere layer 3. It should be routable. So, and let's take a look at some specific use cases, how we implement this solution and how nowadays customers can use it. First of all, it's wired mDNS. Basically, what will happen, you have all your layer 2 switches, you bringing all these VLANs up to wireless controller, you do layer 2 flooding, and in this case scenario, you will able to advertise all services up to wireless controller. Wireless controller will store it in its cache, and afterwards, when wireless client asks for this service, it will work as a proxy and provide all necessary information. But what about when you cannot do it? If you have some specific limitations on policies, or it's just physical location doesn't allow, what you will do is mDNS on access point. In this case scenario, you will breach all these VLANs from your switches up to access point. And in this case scenario, access point becoming in monitoring stage, and it will send all this data from the CAPFWAP directly to wireless controller. And it does not send only services. It will send your IP unicast, it will send you any unicast data, it will send you broadcast and multicast. It will send everything up to wireless controller. You don't extend your services. You just provide everything to wireless controller and ask him to handle it. So again, it's not good from the performance perspective as well. Same thing for the remote offices. When you're using Flex mDNS, for example, in this case scenario, you do layer 2 trunking up to all your access point, you bring all these services, and in this case scenario, access point will make sure what it distribute services to your clients who connect from the wireless. And it will work good without any problems in the small and local environment. But if you will try to scale this solution, it will bring you possibility to have loops in your network. And afterwards, will be same for embedded wireless controller in access point, but one main change and difference will be here what one of the access points will be main responsible for any other access points. And even in current solutions in SDA, until we invented wide area Bonjour, we were saying, okay, to make these services routable in access points what enabled in Fabric, we need to extend our layer 2 VLANs to our edge switches. And this is going even against of the solution of SDA, because with SDA we want to make a robust layer 3 network and not layer 2. So all these challenges together may even bring impact on your hardware itself, not only complexity of implementing this solution in your enterprise networks environment. Because of this mDNS flooding, if you have massive university or hospitals, multiple floors, multiple devices, and you have everywhere layer 2, just imagine how much its traffic will happen, how many advertisements, how many queries will be. All this can impact in high CPU utilization and memory utilization on your hardware devices. As well, it can potentially utilize all your TCAM memory utilization. And in this case scenario, you will not able to forward any IP packets. Because of it, access point may lose access to wireless controller, and it will start reloading. And all this together may bring poor Wi-Fi signal for all your end clients, where you will have poor connectivity, poor bandwidth, and so on. And even on your endpoints, you may have some impact, because if you will run Wireshark and you will see how much mDNS traffic can PC advertise and analyze, it can drain its battery, it can increase its CPU. And due to all these challenges, industry would like to have a solution what will provide you a solution without no boundary for wired and wireless devices, where it will be possible to interconnect them, to have it without layer 2 flooding. It should be scalable. It should be not demanding high performance from your network devices and users, and it should be easy to deploy. Of course, it should be secure, because we would like to know what mDNS we can advertise, what services we can advertise, and we would like to control it. And finally, of course, we want to see services as close to us as possible. Nobody wants to see available printers in 2 buildings away from you. So we want to have allocation services. And with micro-location, what we'll cover today during the presentation, we will take a look how it's possible to do with Cisco and wide and local area Bonjour. So let's take a look how we're addressing all these challenges and how we're trying them resolve. First of all, we will have our layer 2 devices. It can be Catalyst 9K controller or Wireless 9800 switch, where will be in service peer mode. And to these devices will be connected all your end devices, what will query or advertise all your services. It doesn't matter. Afterwards, after this advertisement, we will send all this information to your layer 3 switch, what we call SGT. And in this case scenario, it will form your local area Bonjour. And all these advertisements will be sent from service peer to agent based on the policies. And in this case scenario, the net center is optional. So you don't need to have it. If you would like to advertise services between your layer 3 agent and multiple service peers, you can do, and you don't need to have the net center. But if you would like to have routing between one agent to another, in this case scenario, you will need to have the net center, because in this case, it will become a hub and spoke topology, and the net center will be main data storage for all your policies, what you would like to advertise from one agent to another one. And it will be called wide area Bonjour. So we will take a look exactly when we need to use wide area Bonjour or local area Bonjour in a bit. And one of the main features, all these advertisement, all these services will be sent in unicast manner. Starting from service peer, we do not need to have any mDNS flooding. And going from agent as well. Everything will be sent from the unicast. You will not have any more flooding in your network. And because of it, because of its structure, we make it's very highly scalable. Because if you want to scale it, you have one point of contact, the net center, for redistribution globally, all the services. So it's very high scalable solution. Afterwards, it's secure, because we will use policies for controlling what services we want to advertise, starting from the service peer, starting from port, from where its service is connected, or from wireless, where your end users are connected. And definitely we will give you location possibility to configure based on micro location, what we will take a look in the future. So you will able to control what services you want to advertise on what floor, for example, and who can see them. And definitely performance, because we removing mDNS flooding, it's better for your network devices. We need to access, we need to read and see less information, and also your end user devices will see only mDNS traffic, what should be advertised, and that's all. So it's increasing your performance as well of your network. And I spoke with a gentleman in the studio who was asking where we can use these services. So let's take a look about it. First of all, we can use it in the schools or universities when we have multiple offices or locations or buildings. And in this case scenario, definitely in these buildings, we will have printers or TVs where students want to share some presentation or just any services to connect. And you can use it where you can do even a segmentation by that. For example, if you have specific floor where have access only teachers, so students will not able to see any services from them. Only teachers with the right access will able to see it, so we can configure it. Same thing from in hospitals, when you have, for example, doctor and patients located in one room and they need to access the same device, same applications, they will able to do. As you know, if you have a patient, he will be most probably connect to some guest wireless, and your doctor will connect from enterprise wireless. But in this case, both of them will able to have access to the same device in the same room. It doesn't matter from what SSID it's configured and from what SSID way joining. And same case happening in our enterprise environment. Because nowadays, a lot of people bringing their laptops, we have a lot of different WebEx systems or any communication system where we want to connect and we want to use these services. This is not a problem. We can do it as well. And even in any possible sectors like financial, public sector, transportation, retail, it doesn't matter until if you need to using mDNS, you can configure it. We do not have any limitations from it. You just need to have right equipment and right configuration. And since 2019, this wide area Bonjour in the Night Center was installed more than 7,000 times. And I hope after this session, this number will increase a little bit. Okay, and so let's now speak about when wide area Bonjour it's needed and when it's local area Bonjour needed, and what's the difference. So, in simple answer, you will use wide area Bonjour when you need to do layer 3 routing from one ASD agent to another one. But why you would like to use it? For example, if you have your local network configured from wireless, and in this case scenario, all your services, all your in all floors connecting from your switches, and all access points connected to the same switches. But wireless controller dedicated in somewhere in data center across all your network. In this case scenario, for routing and advertising services from access points, you will need to use the Night Center. And it will become a main hub. But in case if you have small office, small branch, where all routing happening in the same building, in this case scenario, for example, if you have embedded wireless controller in access point, you don't need to have the Night Center, because all routing, all services, all connected in one single building, and in this case scenario, you can use just local area Bonjour. You don't need to have the Night Center. And you may have different multiple scenarios as well, but this is just a regular example. Or if you have specific building where you just want to advertise services locally due to policies, not a problem. You can configure local area Bonjour and that's all. So now let's take more depth information regarding Bonjour architecture and how it's working. In the end, we will have our endpoints. It can be any endpoint what's supporting RFC 6762. It doesn't matter if it will be Apple device or some third party. Until it's supporting RFC 6762, this solution will work. Afterwards, you will have our service peers. It's layer 2 devices, what will be in service peer mode, who will get access of these services and there is distribution. So what will happen, for example, if you have printer, it will send advertisement message to our layer 2 devices in service peer mode. These devices, based on the policy, will check if I can accept it or not, and we will speak about the policies in a bit. And if they can accept it, they will store it in the local cache, and we will send to layer 3 distribution agent, your SDG agent. And how we will send it? We will send it by using layer 3 IP address from your existing trunk, layer 2 trunk, what you configured. So you don't need to do any configuration changes from here. And afterwards, your agent will become main distribution machine what will store all these services for your all service peers what connecting to it. And it will become your local area Bonjour. This is how it will work. Even you may not have in some small office your service peers, like layer 2 switches. You may have only layer 3 switch. It will work as well. In this case scenario, you will use just agent as access for policies and distribution. And when you will need to give some services from one agent to another, as I mentioned before, we will use our denied center. And in this case scenario, again, based on the policies, what we'll take a look in the next slides, agents will send this information to the denied center. And the denied center will also have a policy configured and will check if he can accept these services or not. This is why it's so secure solution. And honestly, it doesn't matter what IP network you're using, because if it will be regular IP network, for example, OSPF protocol or MPLS or VXLAN, it will work. We're asking for you, just for this solution to work, have IP reachability from the denied center and your agents. You don't need to do any additional configuration from its side. And now, of course, definitely, if you have your service peer connected and you just need to do inter-VLAN routing, it's supported by default. You have your policies. And for example, in service peer 1, we have endpoint user who want to get access to our printer services. And afterwards, we have this printer available on service peer in VLAN B. In this case scenario, by default, service peer will do a local distribution of these services. And in this case scenario, you don't need to have, we will not send any request to our agents or the denied center. Afterwards, if you want to have and configure redistribution of the policies between service peers, you can do it, and you can say, for example, to what service peer you want to redistribute services and what service peer should be standalone. For example, as you can see, our agent will redistribute in unicast manner service policies from service peer to service peer 1 to service peer 2, but it will not redistribute any services to service peer 3, maybe because of your some specific configurations or limitations or security possibles. So we giving you all this complexity, all this functionality to configure as you want and redistribution with services in your network. And now let's take a look how exactly routing is happening, because it's very important to understand. So as you can see, on your left side, we have a printer who's sending announcement. And first of all, what we will have our service peer in its layer 2 switch. In this case scenario, by default, this announcement will be accepted. I will explain in next slide why. But for example, if we will use custom policies or policy does not accepting this advertisement from this printer, this mDNS packet will be dropped immediately. This is how you just limiting what you want to see in your network or not. Afterwards, this information will be saved in the cache of memory of the service peer as well. And we will send this advertisement message to our SDJ agent. And again, by default, it will accept. But if you want to make some custom policy, you can do it. And in this case scenario, this packet will be dropped. SDJ agent will send this save it information in its own cache as well. And afterwards, it will redistribute to the denied center. And here, what will happen? The denied center have very strict policies. And if this policy, for example, does not allow this packet to be accepted, or if it's not meet specific criteria, it will be dropped. So what criteria we can configure? We will need to specify in the denied center from what switch it's connected. If it's connected to SDA agent directly or to service peer, on what port it is connected, on what VLAN it's using. If these criteria are not matching, this policy will be dropped from the denied center. And same thing will be from receiver side. So now let's take how it's working from the receiver side. So we have our client who want to print some documents. He will say a query response, hey, do I have any printers in this environment? It will go to wireless controller who is in service peer mode. And in this case scenario, wireless controller will check policies. And definitely for this example, it will accept it. And it will send back to the distribution. And in this case scenario, SDA agent will check its local cache and see if he have any information about the printers. If he will have any information about the printer, he will just back response to the client, and client will establish connection with the printer. But in case, if he don't have any information about it, he will ask the net center if we do have any printers on our network environment. And afterwards, the net center, based on its policy, will check if this receiver, who is connected to a specific SSID or VLAN, is having access to this printer. And if he have access to it, in this case scenario, the net center will send a response with all necessary information for end user get access to the printer. And it will be sent to distribution agent, afterwards to the service peer, and service peer will send this query response to our endpoint. And here, this is very important factor. Local area Bonjour and wide area Bonjour, it's done all its work. What will happen next? Based on your network topology, if you're using regular IP networking, or if you're using SDA or MPLS, communication between end user and printer will be established based on your routing protocol. For example, if you're using OSPF, it will use OSPF. We don't do any configuration changes to your network. This is why it's so simple and versatile to install, and why we're supporting multiple implementations models, and we will take a look exactly what. Because we do not introduce any changes in your existing network, and I want to keep it in mind. And what about micro-locations? And in this case scenario, we have policies, we were speaking about it, but how you do location filtering, and we can speak about it. So let's just imagine we are in the campus network. We have multiple buildings. Oops. And in this case scenario, definitely we don't want to see all the services from all buildings. And in this case, if we will go to the building one, we would like to see only services what are advertised in this specific building one. And we can do micro-location per building level. And in this case scenario, we will include all devices what connected from the wired or wireless side. For our solution, it does not matter. You can do it. But definitely, if you have like 5 floors or maybe 10 floors building, you don't want to see all the services from all floors. You just want to see available services on specific floor. And in this case scenario, we can do it as well. You can see all the services what are available in each specific floor. And moreover, when you will roaming between these buildings or between these floors, all services will be automatically updated on your end user device. You don't need to do any configuration changes from it. It will be automatically done based on the tags, and I will explain you how it's working in the next slide. But what if you have some requirements on, for example, you have some place in the office where certain people can have access to it? Not a problem as well. We can do micro-location per zone level. So you will able to do segmentation on it. And only people who are locating in specific floor and connected from specific wireless SSID, for example, or even wired, they will able to see the services. So we can do it. And if you would like to see any specific configuration examples, please go to the appendix and you will see even how we configure it. So you will have an example of it. And with this solution, we provide to you very granular filtering, so you can know how to advertise and where to filter with services. It's best in class. It does not require it from wireless or wired point any configuration changes in your existing networking. Definitely, you will need to add some new configuration, but you don't need to change any existing. And this is one of the most important part. And afterwards, you can configure it across all your network as well. So how it will work? As you can see, it's a same example with service routing, what was done before. So as you can see, nothing is changed. It will be all the same. You will have same policies, but to policy, you will add mDNS tagging. And this is how we are able to track where is connecting your service and where is your client and match it. So basically, what will happen, we will tell to service peer or SD agent or the net center on what port it's connecting to your wired services. And afterwards, from the wireless side, we will give tagging on access point. And when we match all together, end user will able to see only services what are available for a specific tag. And this does not require any configuration changes again from your existing configuration. You just add specific tag for mDNS. So now we understood what is it, wide area Bonjour and local area Bonjour, what's the difference and benefits we may have. Let's take a look what exactly we need for it to work. And from Cisco side, you will need to have a DNAT sensor with local area Bonjour running at least on 2.2.2 software version. Definitely, you may find configuration with lower versions or older versions. But in this case scenario, not all functionality will be supported for wide area Bonjour. May be supported. Afterwards, for Catalyst 9800 switches and wireless controller, same 17.6.2 software version should be running to support all this functionality, what was introduced during these slides. And also, we even start supporting Nexus 9300, but this device may have some limitations. For example, at the moment, we do not support unicast communication with service peers. And because of it, we cannot do multi-layer LAN unicast deployment for Nexus devices. If you would like to see more information regarding what necessary license you need to have and in what mode can be Catalyst 98 switch, it can be or in service peer or SDA mode, please go to the appendix and you will have a lot of information there. I just don't want to boring you on Friday with it, so you can find it there. And afterwards, for wireless controller, it can be only in service peer mode. It's important to remember. Definitely, Mac, Apple devices will work with any problem in your environment because by default, they support Bonjour or mDNS. And afterwards, you can support any services what supporting RFC 6762 will work in your enterprise environment as long as services was following with RFC. So this is why it's so versatile, and it doesn't matter if it's Apple device or, I don't know, Android device or anything else. We just need to support RFC 6762 from the end user clients and devices. So it was a lot of information regarding what is solution and how it's working. So now let's get a little bit more how to configure it. As you remember, I was speaking a lot about the policies and I was mentioning default policies. From Cisco side, what we are trying to do is make your life easier and do as less as possible configuration from your side. And what we introduced default policies. So when you configure mDNS on your service peer or SDA agent, you will have already enabled by default and configured well-known services like AirPlay, file sharing system, Chromecast, and so on. And afterwards, policies, service list policies, and policies itself will be automatically built. So you don't need to do any almost configuration except enabling mDNS and provide and saying on what VLAN you want to use, and we will take a look during the configuration. But what if you have some specific services? Not a problem. In this case scenario, you may have custom policies where you will configure all the configuration what you need by yourself and provide possibility of routing custom service. Or maybe if you have some strict policies and you want to allow only specific services, you will use custom policies. So let's take a look. We will not stop for long what exactly is happening here, but what will happen by default, we will build for you in local area Bonjour, local service list, and afterwards we will apply this service policies for your local wide area, local area Bonjour, and afterwards we will do same default built-in policy for wide area Bonjour, and we will do default tagging and location filtering for you as well. If you want to do custom mode, you can do it. We're providing all possibility for you to do a custom configuration. And before we'll continue for exactly how to configure, let's speak about a little bit about the policies and why it's so important and how they are working. You may think about policies as some type of the access list, but for services. So it doesn't matter if it is SD agent or service peer, you will need to configure, or by default it will be enabled for you already, ingress policy. So what it will do, it will tell to a device what exactly policy he can accept from end user or from services. Same thing, you will have egress policies, it's optional, and by default it's configured as well. If you want to re-advertise this service to another VLAN in specific case or another service peer, you can configure egress policy as well, but by default we have it. And afterwards, for wide area Bonjour, on SDA agent, you will need to configure egress policy to tell SDA agent what policies you want to advertise on global level. You need to do it. By default, we have it. And afterwards, we will have a wide area Bonjour from the DNS center itself. It will be permit bidirection communication between SDA agent and the DNS center itself. And if this policy will not match any standards from services what SDA agent will try to send, for example, it will be dropped. It will send implicit deny for any remaining. And this is how we make your environment secure and manageable from IT department. Now you can control what mDNS services advertisement you have in your network. And starting from service peer, anything what you don't want to see in your network, it will be dropped. So on customer access level. And for some deployments, when you want to use wireless access, you need to have wireless multicast enabled, because by default, Cisco Catalyst wireless controller and access points will not forward any IP multicast in layer 2 or layer 3. So for this, just for reference, to enable it, you will need to disable on wireless controller mDNS snooping, enable global multicast, and afterwards enable IP multicast. And on the distribution level, you will need to provide a configuration to do PIM routing for your multicast information. And what we did in Cisco, starting from 79 software release and onwards, for configuration for wireless controller in local mode or flex central, mDNS multicast, IP multicast becoming optional, so you don't need to configure it. It's not mandatory. More information regarding in what deployments and environments you need to use multicast, wireless IP multicast, you can see in the appendix. And now let's take a look and speak about how we can configure our wide area and local area Bonjour using default configuration. And most probably I will explain for more longer time my topology rather than explain configuration itself. So on service peer side, switch 1, we will have two users who are connecting to VLAN 20 and 10. Afterwards, switch 1, its layer 2 access device, will have a layer 2 trunk to our distribution switch in layer 3, what's called SDG1. And it will have configured VLAN 99 for management. And definitely, it will advertise all these VLANs in trunk port. Afterwards, our SDG1 agent will be connected to some IP network existing in your environment. No changes here. And it will have direct connectivity as well to and reachability to our DNS center. And as you may notice, we have configured loopback address. We highly suggesting from Cisco side to configure wide area Bonjour by using loopback address or from your switch. And from the user client perspective, we will have switch 2, what as well connected to our IP network, have loopback 2 configured, and afterwards we will have our wireless controller configured on this side, and we will have again in layer 2 trunk, as you can see, our client will be connected to VLAN 50, and we're using VLAN 99 for management purposes. And afterwards in VLAN 50 will be all our clients. And as you may know already, layer 2 devices will be in service peer mode, and layer 3 switch will be our SDJ agent.
Sorry.
Yes?
In a DNA infrastructure, where are located the SDJ agent? On the access switch or the border?
For DNA infrastructure, we will take a look on this. I will explain it in topology. This is just example of how wide area Bonjour will work, sorry, I forgot to mention, in local mode for enterprise solution. Okay. So regular traditional IP networking, not SDA.
Okay.
So I hope I was able to answer. In this case scenario, honestly, we may not use service peer. We may have only SDA agent. But for full for full solution, we have all in. But during the demo, we will see how to configure the solution to work only with the SDA agent. And question was why we're using here service peer, and it was related to SDA in general, because in SDA we can use different distribution agent for. Anyway, we'll cover it in a bit. Sorry. And so yeah, first of all, what you will need to do between service peer and SDA agent, you will need to configure mDNS trust command, and that's all. From wireless controller, wireless controller side, we don't need to do it. And afterwards, we will start configuring our service peer. In service peer, what we will need to do first, it's enable mDNS. How are we doing? We're saying mDNS gateway. And afterwards, in mode service, in mode, we will specify in what mode we want to be. If we want to be in service peer or in SDA agent. We're saying service peer. And last thing, what we'll need to specify and configure, it's connectivity and saying where is our SDA agent. So we will need to provide IP address of it. And we're providing IP address from the management VLAN, if you will take a look in VLAN 99. And next thing and last thing, what you will need to do is just enable mDNS gateway and functionality and advertisement of these services on VLANs where you want to have. From one side, it will be VLAN 10 and 20. From another side, it will be VLAN 50. And gentlemen, this is all the configuration. What you need to do on the service peer. Same thing will be from SDA agent. What we will need to do first, it's enable agents in SDA agent mode. You can see. And next thing, what you will do, it's configure and enable services on your VLANs. 10 and 20 from one side and 50 from another. And all this configuration was done for configuring your local area Bonjour, for your services what already built in our devices. Next, what we will do is configure wide area Bonjour part. So in this case scenario, if you don't want to have any routing between agents, you're done. It's all configuration what you need. But in case if you want to advertise services from one agent to another, we will need to configure wide area Bonjour on agents. And what we will do, it's specify policy, what will say where it's our DNet center by providing IP address, and afterwards we will say what interface we want to use for communicating with the net center. And this is all configuration what it's needed for you to configure wide and local area Bonjour using default method. And all the policies will be already configured by default by us. You don't need to worry about it. It will be already implemented in these switches. And next and last thing, right now we will just covering 3 steps what we need to do, but during the demo, I will show you exactly how we're doing from the net center. You will need to create your root domain, you will need to create your subdomains, and afterwards you need to configure source and query policies. So just keep in mind these 3 steps what we will need to do, and we will cover during the demo. And afterwards, what we can do from the Catalyst side, we will able to run multiple show commands where you can see if your connectivity to the net center is up and running, if you have any information in the cache on your service peer or on your SDA agent, how many packets it's sending. So basically commands for troubleshooting or just if you're interested to see if everything working as expected. And now let's take a look on the supported designs, and I will go exactly for SDA and show you how it's working there as well. So, first of all, let's take a look in our traditional LAN network environment support, and most probably you will see all supported designs here already because we discussed it in the previous slide. First of all, we will support just routing access. It's meaning when you have small offices and you have only layer 3 switches. In this case scenario, you don't need to have a service peers because you don't have layer 2 switches. In this, what you will do, just configure layer 3 switch as an agent, and it's done. An agent will collect all the services from connected users to it and distribute to the net center in wide area Bonjour if you need it and you want to have this routing between them. Second one, what we covered already multiple times during this slide deck, it's multi-layer, where you have your access layer as layer 2 switches, and afterwards you will have layer 3 as in distribution side. And finally, what if we have legacy support, legacy devices, or for example, some Catalyst 9K switch does not have specific license, or if we don't want to do any changes in existing enterprise environment and we want to test this solution, not a problem. In this case scenario, what we can do, and we support ship and night model. So what you will need to do to existing your IP gateway, you just need to connect another Catalyst 9000 switch in SDA mode. You will need to provide same layer 2 level, layer 2 added to same layer 2 management VLAN, and provide one extra IP address for agent to be able to get access to your service peers. And if needed, to redistribute these services between multiple service peers or connect to the night center. So we can support this. It's not a problem as well. Now let's take a look regarding wireless devices. First of all, we will support our local mode. Of course, we already covered it. It's not a problem. In this case scenario, a wireless controller will be in the service peer mode, and SDA layer 3 switch will be in our service peer mode. Same thing will be for Flex Central. Nothing is changing here. We will support it. In Flex Local, we will have some configuration changes. As you may know, in Flex Local, control plane will still go to the to wireless controller from access point, but data plane will go directly from the switch. And in this case scenario, what you will need to do is just configure layer 2 switch to be a service peer. You don't need to do any configuration on wireless controller. Or if access point is connecting directly to layer 3 switch, in this case scenario, just configure as the agent. And no configuration needed on wireless controller part. Oops. And as well, we're supporting configuration for embedded wireless controller on access points. It's not a problem as well for us as too. Now let's take a look in the SDA deployment, and I hope I will able to answer one question why we're using, if we need to use service peer or not, or we just implementing agent on it. So first of all, if we have full integrated SDA, what I mean by this wireless and wired environment, it's full in SDA environment enabled on wireless devices as well. So what we will do, on our edge devices, we just enable SDA agent. We don't use service peers. You just immediately enable SDA agents. And same will happen with wireless controller. You don't need to do any configuration on it because of the solution and SDA, how it's working. And it will work. Please let me know if I will answer on your question. Thank you. Secondary, if we have Fabric enabled on wired part, but wireless, due to some reasons, it's not enabled for Fabric, or it's just basically over on-the-top solution. In this case scenario, not a problem. We can support it as well. On Fabric mode edge devices, you enabled agents. And where you have your wireless controller, you configure it as a service peer. And afterwards, in distribution agent, you enable as well agent mode, and that's all. And we're also supporting embedded wireless and a policy extended node for your SDA solution as well, without any specific problems. But we're not stopping here only. We're as well supporting BGP, EVPN, VXLAN support for wired and your wireless devices if you don't use SDA. And what we can do, we will support your Fabric layer 2 overlay scenario. In this case scenario, on your lifts, you activate SDA agent, and it will work. As well, if you have your layer 3 overlay, it will support, again, on the lifts, you just activate agent. We will support, again, symmetric IRB, not a problem here, asymmetric, and as well, we will support centralized wireless in local mode in this configuration without any specific problem. And why this solution is so versatile? Because we're using hub and spoke topology. Because the night center becoming main data point for routing services. If you're using mesh topology, it will be not scalable, because in this case scenario, each SD agent need to contact another agent to have specific information or services. It will be quite quite heavy on your deployment. And in this case scenario, let's take a look what scenarios we can use and what we can use. First of all, it is point-to-point. In this case scenario, you will just specify one query from one site, and afterwards you specify another source site on denied center policies, and you will able have access to it. Only one limitation from each side: one query can access to one source. In this case scenario, what we can do, multi-point to point-to-multipoint. We may have several queries configured in policies in the denied center who will have access to one source. If it's not enough, or maybe you have multiple services what you want to advertise, you can do multi-point to multi-point. You just configure these policies on the denied center, and you specify who can have access to what source, and that's all. But in this case, if you want to get some information or understand what mDNS traffic you have in your network without advertising it to any other agents, in this case scenario, what we have is standalone mode. What will happen? You configure your you will send from SDA agent information regarding your services to the denied center, and in the denied center you will configure policy what will accept all this information but not will send anywhere. And why you will do it? You will able to see what services you can advertise, and you will able to see even some information from telemetry point. So we have this possibility as well. And right now, let's take a look and speak about high availability, what we support and what don't we support. Definitely, we support high availability for the denied center. So if you have your denied center in stock, we will support it. Not a problem here. Afterwards, if you have your devices in a stateful switchover, we will support for Cisco stack-wise switches. We will support for modular system. Or also for Cisco stack-wise virtual, if you have a solution as well. Oops. Or for Cisco wireless HA model for wireless controllers. Not a problem as well. And what about HSRP-aware solution? We can support it as well. We can support it for wired solution when you have it, and also for wireless. So we're trying to make it very versatile and very robust to satisfy almost every your deployment model just for you to work and implement it. And I think right now we're coming to the most interesting part. It's demo part. So again, I will show you some demonstration and topology. And honestly, when you will look at topology, you will able to see its mix of different topologies combined together. And it's just showing to you how the solution is versatile. So what will happen? We will have our access point, what will be in flex local mode. So what it's meaning, we will have a control plane going to wireless controller, but data plane going from the switch. And we will have only one switch, what will be in the mode of SDA agent. We do not have any layer 2 switch, so we don't have any service pyrams. And definitely we have configured our layer 2 trunk and our client in VLAN 200 here. Afterwards, we will have ISR 4K. Who will do responsibilities for routing, and we have OSPF configured routing here. From another side, we will have H2. Again, it will be our SDA agent configured in this case scenario. We have on H1 and H2 all configured loopback addresses, and afterwards we have VLAN 300 where we have our Apple TV configured and connected directly as well to the Edge device too. And afterwards, we have the denied center. So this is all our topology, what we will use for it. And let me go and switch to my demonstration. OK. So as you can see, in this case, we will use the denied center with version 2.3.3. And I just want to highlight it's a pre-recording demo, but it was done in real-life environment, so it's working. Because lab was located pretty far away, I just don't want to risk it here. So this is why it's a video here. So first of all, what we'll do, we'll need to create templates for our deployment, where we can find it in Tools and Template Editor. So you will need to configure templates on your network environment only one time, and afterwards you can deploy it easily. So it's time-consuming only first time when you writing the configuration. In this case scenario, we have already pre-configured two templates, one template called local area Bonjour, another one called wide area Bonjour. And right now, we will follow together from them. So let's take a look in the local area Bonjour. And so I hope it's clear. So what we will do here, again, we're just saying for our edge devices, we will use them as in SDA agent mode. Afterwards, you can see we're configuring a policies. We're configuring service list. So we're saying what traffic we want to accept from this edge. We're saying match Apple TV. We're saying I want to see only traffic or services what have this specific advertisement, Apple TV. And same service list, second one, what we'll configure, we have out, seen outside, for sending this information to another devices if we need. And next command, what we'll do, we will configure service policy. We're providing a name, and we're specifying what policies, service list will be configured under this specific policy. We're binding them together. And last thing, what we will need to do for policy to work correctly, under VLAN configuration, and you can see here we're using interface. It's a scripting. So during the provisioning, you will just specify on what interface we want to activate this specific feature. We will just specify service policy what we configure. And that's all. This is how we do custom configuration if you have your unique service, or maybe you want to limit to some specific service and you don't want to advertise anything else. And this is configuration for your local area Bonjour. And what will happen for wide area Bonjour? Pretty simple as well. If you remember, during the slide when I was explaining to you, we need to specify policy, what we will send, what will differentiate what information agent will send to the net center. It's here. You configure in the first line, mDNS controller service list, provide any name, and you're saying, okay, I want to send out only information to the net center with Apple TV. I don't want to send anything else. And you assign this policy, service list, to service policy. You may have different service lists assigned, but in this case scenario, we just have one. And you assign this service list to specific policy. And as you may know already, what will happen next, you're specifying information on how to find the NAC controller in policy, in service export and DNS control policy. Afterwards, what you will need to do is provide IP address of the DNS controller itself, assign policy, what we configuring in previous steps, and again, say what loopback interface we want to use. And for this case, we again using scripting. So during the provisioning, you will able to specify the specific interface. And for use of me, I just create a custom compose template. Why it can be useful if you have multiple buildings, for example, and you have slightly different configurations, and you know one template will be solidified. For example, wide area Bonjour on all your edge devices will be the same. You create one template, and if you know local area Bonjour configuration can be changed, you just create templates, base it on the floors for it, and afterwards you combine in one composite template. It's easier for you, and it's more modular to fix it. And what you will need to do is just to go to the design and make sure what this in network profile, you assign all these templates, because many times people cannot understand why we cannot see these templates during the provisioning, because we're not assigned for the specific profile. And what we will do next, it's simple, just to provision our devices to activate these services on them. In our case, on H1 and H2, we will activate them and we will make them work in as agent. So what will happen here, you can see two devices and the net center asking us to provide specific configuration for them. So we will configure our H1, we will provide VLAN ID, and VLAN ID, it will be 200, basically where our client is connected, and afterwards we will provide same IP loopback interface 101, and same configuration we will do for our H2. We will provide in one VLAN we want to configure our services. It will be VLAN 300, and as you can see, I make a typo, so I will change it here. And afterwards, you provide same loopback address what we have in agent 2, H2. And afterwards, just double check what everything is correct, and we will click next. And we will do provisioning. During this provisioning process, I speed up the speed of the recording, but in real time, it will take you several minutes, maybe 5 to 10 minutes to deploy it. So we can go and make, for example, some cup of coffee. So it's pretty easy. You don't need to do anything. Just wait. Okay, and as you can see, it was done. Provisioning was successful. Next, what we will do, if you remember when I was speaking about the net center configuration and these 3 pillars, you need to specify policy and your domain and so on the net center. So we will do it right now. We will go for it for tools, and we will choose wide area Bonjour dashboard. And this will be your main dashboard for you to use for wide area Bonjour services. So as you can see right now, it's pretty empty. But here, when you create your domain, you will be able to see subdomains. We'll speak about it, what exactly it is. You will be able to see all your policies, what you're applying, what SDA agents you have, and what service peers you have. And afterwards, you will have all information regarding what services was accepted by a DNA agent or dropped. And you will see some like fancy things like top 5 subdomain services of top 5 SDA agents who used the most. So to configure your domain, we need to go for configuration. And if you will be first time configuring this solution, you will be asked to provide a domain name for your domain. And I want to highlight one thing here. All this configuration, it's logical and it's only related to wide area Bonjour. It will not affect any topologies or hierarchy what you have in your DNet center. It's just for your reference and for your use case and for your understanding how and where it will work. So I will provide the domain name Acme, but honestly, if you have some previous configuration, you can import it completely using XLS file. We will create a domain. And as you can see, a domain was created. And afterwards, again, it's logical tree. It's up to you to design and understand how it will work. In my Acme Corporation, I have floor 1, where I want to provide all these services. So I will say it, floor 1. And in this case scenario, will be created subdomains. And I will apply to floor 1 specific filters for our Apple TV to be working and able to be routed from one edge to another. So I'm going to floor 1 subdomain. And afterwards, I'm just clicking on this purple icon, this document, and it will give me information to create a possibility to create a service filter. And here, where it's all magic, it's happening for the DNet center to accept or drop the policy. First of all, what you will do in network mode, you will specify if you're using your traditional IP network or if you're using SDA or any overlay networks. Again, you providing the name. You providing the name. Name, again, it's optional for you, not a problem. And if you want to provide more information, you can do it in description. And another part, what is important, in service type, you will specify what services will be affecting it. If, for example, Apple TV, we want to see, you specify it here. And in this case scenario, the DNet center will check, okay, if I can see with Apple TV services, what I can do with it. And you can specify multiple, but in my case, I'm just using Apple TV for reference. And next, you creating a policy relating to source and query. So you will provide more information for the DNet center to know from whom he can accept these policies. First of all, what you will need to do, specify SDA agent here. And as you can see, on top, we're specifying a source. So from where this information will going, who will advertise these services. In our case scenario, it will be H2 switch. We click on it. And next, what will happen, we need to specify service layer. So what does it mean? If you have your service peer in your network topology, you will need to specify a peer here. If you have only SDA agent, you need to specify local. I know it's a little bit confusing, but this is how it's work. So you specify local if you have SDA agent only, and peer if you have multiple service peers. And here, you will specify from what VLAN we want to get announcement for the specific services, and automatically you will have IP subnet. If you have a service peer, you will need to provide peer ID, and afterwards, if you have location configuration, you will need to provide specific location information or location group tag. But right now it is in default mode because we didn't configure it. And you need to save it. And we configured policy from the source level. And for query to get access from it, we need to configure right now query. Otherwise, a device from VLAN 200 will not be able to get access from it. And what we will able to do, it's in type, click on the query, specify SD agent where our query is coming from. Again, specify if it's connected directly to SD agent or from service peer. Specify in what VLAN IP we're waiting advertisement. And again, we will have all information already populated. And we need to click on the done and create. And honestly speaking, on this step, we already finished all configuration. So what we did, we configure local area Bonjour and wide area Bonjour on our enterprise devices. And afterwards, we finish configuration on the policies from the net center side. And now the most fun part to see if this solution will work. So we will go right now. I hope. It was on pause. So, oh yeah, sorry. Before it, we even can check if these policies are applied on our SD agents and if they're available. For this case, we're going to monitoring to SD agents. Again, magic of speed up. But we will see here all information regarding of our agents, what management IP address we have, what interface we're using for source, where we're locating, what policies we're using, in what stage we are in source or query, and if they're working or not by state. As you can see, before it was red, and right now it's green. So now it's everything ready, and now it's testing time. And now you may notice we don't have Apple TV, but we are reproducing mDNS here, so it's like workaround. And if you will see on top left, top bars, we have from one side Apple TV name and from another employee side. So from Apple TV, in our case, it's just a Windows machine, but we will start advertisement of our mDNS traffic, what we will call Cisco Live Apple TV. And afterwards, we use AirPlay tag for it to be advertised. It started. And below, on employee side, we will just asking for query if we have any Apple TV in our network. And as you can see, we was able to get information regarding Apple TV and domain and all this information. So it's working, looks like. And in this case scenario, let's go to our DNet center and confirm if it was done all correctly. We will go to our dashboards. And we will able to see what information was accepted or not. So I will specify exact time when I made this advertisement from in the net center. I will apply it. And as you can see, it was we can see with all information. We can see what services were accepted by the net center and advertise it. And below you even can see in what floor, what agent was using, and what service was advertisement. And to understand more information, we can go to the monitoring and services, and here you will see all services what was accepted by the net center. You will able to see what we accept Cisco Live Apple TV. You can see from what domain we accepted. From floor 1, we can see filters, IP address of SD agent, service type, and information about even instance who advertised this service and what IP address it's having. And this is all from my demo site. So let me just go back to slide deck. And I really hope presentation was clear and you was able to understand how simple it is. Question?
Yes. If we are in a DNA infrastructure,
yes.
Maybe your client and your service is in two separate segments. SGT or virtual network.
Mm-hmm.
Does the communication need to be accepted by DNA? Does there is a contract allowing the communication between the two segments to allowing the service?
So let me rephrase the question.
For example, in a hospital, we have you explained that we have the guest Wi-Fi and we have the medical Wi-Fi.
Yes.
Normally, the DNA doesn't accept a communication between two. But are we able to access an mDNS service with this solution?
Okay, so let me rephrase the question. You're using, if I understood correctly, SDA environment, and you're using different VNs for different users. So answer is yes. So we have, if you will go for appendix and SDA solution, for SDA deployment, you able to see how to do routing between and configuring routing between different VNs, as you mentioned. So you can do routing of the services from VN1 to VN2, and it will be possible.
But we need to create a contract allowing that.
Yes. Yes. It's because it's just
communication.
It's just serves as advertisement.
Yes.
And the connection is
Unicast.
Unicast router.
Yes.
And it needs to pass through the filtering of DNA. Okay.
And what about SGT?
It's the same. It's
but
just a Unicast connection.
What I mean, if you have got in the policy of the DNA that says between SGT1 and SGT2 you are not supposed to communicate. You are still announcing.
But then you can filter using the policies.
That's why.
Yes. So.
With the target.
Gentlemen, just to sake of time of presentation and to not boring our audience, let's just continue with this question. After this, I have some slide deck. I can show you configuration related to SDA and routing between different virtual networks, so we can take a look at it. And next thing, before I will ramp up, I want to say when we will finish, we will have Q&A session, so you may ask any questions, and more than welcome. And what I want to say, today we will take a look and understand what exactly is Bonjour, where it is working, if it's only for Apple devices or not. We was able to understand what exactly challenges we're facing, how Cisco overcome these challenges, and how easy it is to configure, I hope, by the configuration workflow and demo. And afterwards, we was able to see how versatile this solution can be, what you can implement it in regular networking, in SDA or BGP EVPN. And of course, I do not know if you was able to see the slides many times. I do not know if you really can get a still extra t-shirt. But if you have... okay. In this case, please find several minutes and complete this survey, as it will help me to see how relevant this session, how useful it is, and if I need to improve something. So please just find a couple of minutes and try to finish it. And let me just do some quick trick. Okay? And if you're already interested of implementing this solution, please follow these links you have already in the slide deck attached. So you will able to find useful information, depends on your deployment and model and from where you can start. So you don't need to Google it. And finally, what I want to say, this solution will simplify and secure your network substantially. So I just want to leave you with keynote and think about it, how it can be easy with wide area Bonjour and local area Bonjour in your deployment, because you will not have any mDNS flooding and you will have more control. And thank you very much for joining for this session. Be here on Friday and also for joining for Cisco Live. Thank you very much.